To solve this equation, we're going to use the quadratic formula. In order to use the quadratic formula, we need to know a, which is 3, b, which is -2, and c, which is 6. I will now proceed to substitute. So since b is -2, the opposite of b then is 2. So we'll have 2 plus or minus -2 squared minus 4 times a times c. Put that all over 2 times a. Simplifying further, we'll have 2 plus or minus the square root of -2 squared is 4, and 4 times 3 is 12 times 6 is 72. We'll put that all over 6. Continuing to simplify, we'll get 2 plus or minus, now 4 minus 72 is -68, and we'll put that over 6. Now we have a negative under the radical, which indicates that we have an imaginary number. So we'll remember that as we simplify this radical. We will also factor 68. So we'll have -1. And the perfect square in 68 is, in fact, 4. So we can write -1 times 4 times 17. Put that all over 6. Next, we can pull out the -1, which is an I, and we can pull out the square root of 4, which is a 2. So I'll write 2i times the square root of 17. I can put this over 6. We notice that each of these has a common factor of 2, so I can factor a 2 from the numerator. I'll have 2 times 1 plus or minus I times the square root of 17, and that will all be over 6. I can now divide out a 2 from the 2 and the 6, and I'll have a 3 in the denominator. So I'll end up with 1 plus or minus I times the square root of 17 over 3. So finally, I can write my answer as P equal to 1 plus the square root of 17 over 3, or P is equal to 1 minus I times the square root of